Alright guys, so this set of notes is going to cover graphing. It's going to talk about how to read a graph, and it'll talk about the different types of graphs and when to use those types of graphs. So objective 7 is I can identify the parts of a graph. So both of these graphs right here, the first one with the bars is titled Favorite Chocolate Ice Cream. And then the other graph with the line is titled Value of Sarah's Car. Now both of these graphs have a title. That's the first thing that you look for when you look at a graph. You look at the title. That'll tell you what your graph is going to be about. The second thing is it needs to have its x-axis labeled. Now the x-axis is the axis that's on the bottom. So the bottom part of the graph is your x-axis, and it should be labeled to let you know what your independent variable is. So in the bar graph, it's kinds of ice cream, and in the line graph, it's the year. You'll see 2001 to 2007, those are the different years. And then from Rocky Road ice cream to Moose Tracks, those are the different kinds of chocolate ice cream. The third thing, we looked for the x-axis labeled, now we have to find that the y-axis is labeled. The y-axis is the axis that goes up and down. This is where you're always going to find your dependent variable. So this is the thing that's going to depend on you changing the independent variable. For example, with favorite ice cream, it has kinds of ice cream, Reese's Pieces, chocolate, Moose Tracks, and then we have the number of votes that let us know how many people voted for those specific kinds of ice creams. For the value of Sarah's car, it looks like it was highest in value in 2001, and that was around 24,000, which you can see the value of on your y-axis. And then as the years progressed, the value of Sarah's car went down. So the year was definitely the independent variable, and the value was changing based on that. The fourth thing you need to look for is that there's scales on your x and y axis. So for the bar graph, you see 0 to 6. And for the line graph, you see 0 to 25,000. And for the x-axis, you have 2001 to 2007, and then your kinds of ice cream. The last thing you're looking for are data points. So when people go through experiments, they collect data. In the analyze stage, they typically graph this data. So there has to be data points on the graph. Objective 8 is that I can choose the appropriate graph to create based on the data that you get. So we create different graphs based on what type of data we have. So there are three main types of graphs. The first is a bar graph. So this type of graph is used when you're comparing two or more things. If you're comparing types of music, or in the last example, types of chocolate ice cream, bar graphs are really good to use with this data. The second type of graph is a line graph. The line graph is a type of graph that we use whenever we're showing a change over a period of time. So just like with Sarah's car, it showed the value of her car in 1 year, and then as the years went on and there was a change or a period of time, her car value decreased. That's when we use a line graph. The third type of graph that you'll see is a circle graph or a pie chart. And we use this type of graph whenever we're showing parts of a whole. And we usually use percentages. So if you're using a pie chart or a circle graph, if it's half shaded in, that's 50%. So that shows a part of a whole. These are actually really easy to read. So in this page, you see bar graphs. We talked about how we use a bar graph whenever we're comparing two or more things. If you look at the data table, it shows the ice cream type, and then it shows the number of votes for that specific type of ice cream. Cherry had 7, vanilla was 3, chocolate was 7, mango 5, pecan was 3, and berry was 6. So whenever you get this data, the next thing to do is to graph it. And since we're comparing different types of ice cream, we're going to use a bar graph. So looking at the bar graph, it's really easy to see how many people liked which specific type of ice cream. Bar graphs are super easy to read. The circle graph or pie chart that we talked about shows you part of a whole, and they're done by percentages. So the circle graph on the left shows you student grades. It talks about the percentage of kids that got an A, a B, a C, or a D on some specific assessment. You can see that the majority of kids are in the purple section, and that comes in at 42.9%. So the majority of the kids on that assessment got a B. Now, looking at the other circle graph or pie chart, it shows 24-hour time budget for an average school day. So it pretty much shows what you spend time doing on a school day. 34%, the biggest chunk of that circle, goes to sleeping, and then the next biggest chunk, 29%, is when the kids are at school. The other little portions show eating or homework or sports or leisure time. The third type of graph, the line graph we talked about, shows a change over time. If you look at this graph, it has a scale on the left-hand side, 0 to 600. That's the y-axis. And then you have data on the bottom part of the scale, which is the x-axis, and that has months. So that shows you, as time goes on, the scale to the left, it shows how it changes as you progress into different months. Whenever you do a line graph, all you do is when you plot your points, you put a dot where that data point is, and then you just connect it with a line to show how it changes over time. When you're graphing more than one set of data on the same graph, there's a couple of things that make it easy to read. So looking at the graph below, it shows years on the x-axis and profit on the y-axis. But we're plotting the profit of two different companies. We have company A and company B. So when you're plotting a lot of information on one graph, there's usually going to be a key that shows you the distinction between the two things that you're graphing. So in our key, it shows that company A is in blue and company B is in red. Okay, now I just covered that up so you can't really see it. But anyways, when you look at the graph, you can see company A is blue, company B is red. And then whenever they connect at a specific point and you see the two colors cross, that means that they shared the same exact data for that point. So in 2005, or 2004, 2005, it looks like they both made $4 million. Okay? Objective 9 is I can describe what's happening based on the shapes of the graph. So in this graph, this is a distance versus time graph. So it's saying as time goes on, what is the distance doing? Well, looking at the graph on your screen, this graph shows an object that's not moving. It's at rest. So as the time progresses, so if that's 1 second, 2 seconds, 3 seconds, that object has not changed its distance because it's stopped. It's not moving. It's not going a distance, okay? The distance is going to stay the same. Now in this graph we have distance and time as well, but notice the line looks a lot different. So in this situation, as time goes on, the distance is steadily changing for this object. So this graph shows that the object's distance is increasing as time is passing by. So the object is moving and has velocity. That straight line means that it is a constant, okay? It's at a constant speed. This graph looks kind of opposite of the last one. We have a slanted line still, but it starts high on distance and then goes down as time progresses. So as time continues on, that object is going from, let's say, 3 meters down to 2 meters down to 1 meter. Okay, so this graph still shows an object that's moving at a constant velocity. It's just going to be at 0 meters in a certain amount of seconds. This graph has a curve, so it looks a little different. That curve just shows that the object's velocity is changing, and it represents acceleration. So as the time goes on, it's going, it's going, it's going, and then it shoots up. Okay, so that shows acceleration. The object accelerated. It went, and then it continued on, so the velocity was changing. Looking at this graph, it has multiple segments, so we'll talk about it. This first part right here, this part of the graph shows constant speed or constant velocity. That as time goes on, that object is moving. However, once it hits the middle part right here, its meters or its distance does not change. Okay, that means that as time went on, that object was not moving. The distance stayed the same. It didn't go anywhere. The third part of the graph shows it going back down, which still is constant velocity. It's just going back to where it came from. So looking at this scenario, Johnny's mother brought him to school and then came back home for 3 hours. Then she went to the store for 2 hours, which was on her way to Johnny's school. After she was done shopping, she continued to Johnny's school to pick him up and then went back home for the rest of the day. So I think your notes want you to draw a graph that could go along with that data. If you guys would attempt to do that right now, and we will talk about it in class and make sure you guys got the right answers.